if you plug in a 0 to the first limit, you have a 0 in the denominator, right? So plugging a 0 in the first step is not going to work. And then you are thinking, well, can we do something to get rid of the x in the denominator? So look at the function. The x on top is in a square root. So even though that is not a square root, so you have a x plus 4 minus 2, then you have a x plus 2, that still cannot get rid of the x in the denominator. So whenever you see a square root, think about conjugate. So what is the conjugate? Do you still remember that from your pre-calculus or algebra class? So from conjugate, you have to use the opposite sign. So this is a minus, right? So you will have to multiply the entire function by this conjugate. So x plus 4, and then you change the minus to a plus 2. And then you have the same thing in the denominator. So you have the function times a 1, so that doesn't change the function, right? And then the next step is you will have to multiply the top and bottom. So the top, that will be like this. So it's like a minus b times a plus b. It's like just expanding two factors. So let's write the limit. So you always write an equal and then the limit, and then x approaches to 0. Square root times square root, then you have a x plus 4, right? And then you have the square root times 2, right? So that is equals to 2 of that. And then you have a minus 2 times that. So the plus 2 and the minus 2 got cancelled. That's why we use a conjugate. So when we have the minus and plus, think about that. A minus b times a plus b, you get a squared minus b squared, right? So that's why we have a 1 plus for 1 minus. So the plus 2 and the minus 2 square root got cancelled. So let's get rid of the line. And then we have negative 2 times positive 2. That equals to minus 4. And then the plus 4 minus 4 got cancelled. And you will be able to get rid of the x in the denominator. So for the denominator, we will have x times the bottom of the conjugate. X plus 4 and then plus 2. Now we do the algebra. So the top, we have x, right? Limit as x approaches to infinity, we have x and then divided by x times square root and then plus 2, and then you get rid of the x, right? So and then now, I wrote infinity. It is supposed to be a 0. Fix that. 0, 0. So after the cancellation, it is now safe to plug in a 0. So you have a 1, right? So you have a 1 and then divided by 0 plus 4, which is root 4, right? And then you plus 2, and then the denominator is 2 plus 2, so that is equals to 4. So at the end of the day, this limit is equals to 1 over 4. Next problem. So what happened when you have that, when the denominator is not a single term? So you have a 1 minus 1 in the denominator, that is a 0, which is bad. How do we do this? So we use a conjugate, and that conjugate is, you look at the top, that is a 1 minus square root, right? And then you will do a 1 plus square root of x, and then 1 plus square root of x, and then the next step is you will have to multiply these factors. All right. So next line, start with an equal, and then we write limit as x approaches to 1. 1 times 1, that is equals to 1. And then you have 1 times a square root, and then a negative square root times 1 that cancels each other, right? So you have a plus, and then you have a minus. So the minus and plus is gone, and then you have a minus root x times a positive root x. So that is equals to just a minus x. And then the bottom, you have a 1 plus square root the bottom, you have a 1 plus root x. This, you know what, I will just not expand this. I will just keep that as 2 factors, because now I can get rid of the 1 minus x and the 1 minus x. Okay, and then you plug in a 1, and then you have something simple. So you have a 1 divided by 1 plus square root of 1, so that is equals to 1/2. All right, that is not it. So let's do 2 more problems. So the next one, let's make things more complicated. Let's have this. Let's have a limit. Let's use a different color too. Let's use a red. So we have a limit as x approaches to 2, And then we have x squared minus 2x. How about this? Divided by, and square root of x plus 2 minus 2. So when you plug in a 2 to the function, then you have a root 4, which is 2 minus 2, that is a 0. So you cannot just plug in. For the conjugate, this is a minus, right? So you have a minus right over here, and then you will change that to a plus. So this will be a square root x plus 2 and then plus 2. Same thing on top, x plus 2 plus 2. And then you will have to multiply this out. Oh, actually, you know what? For the top, we don't really need to multiply that. Okay, let's move this up. And then we have limit. Let's follow the red. Red. Limit as x approaches to 2. Bottom. Root, square root times square root. Then you have a x plus 2. And then you have a plus 2. And then a minus 2. They just got cancelled, all right? And then you have a minus 2 times positive 2, then you have a minus 2. And then you have a 2 minus 2, so you have x left in the denominator, right? Oh, why do I say 2 minus 2? It's a 2 minus 4. Negative 2 times positive 2. 4. So you have a 2 minus 4, then you have a x minus 2 in the denominator. All right, x minus 2 still a trouble. Let's see what does the top give me. So the top, how about this? The top, let's do a factor. So this, I factor out 1x, then we have a x minus 2, and then the conjugate, leave it right there. X plus 2 plus 2. Okay, next step, approaches to 2. We are getting closer. So this is a x minus 2, right? And then x times x minus 2, the conjugate. Look. X minus 2, x minus 2, our last enemy is gone. So now, no more denominator. It is safe to plug in. Then we have a 2 times 2 plus 2 plus 2. And then this is a 2 with 4 plus 2. And then we have 2 plus 2. 4 times 2, that is equals to 8. And then this is it. Okay, one more. So this one, I will do a limit as x approaches to, let's do a x approaches to infinity, shall we? So how about x divided by, look, I have square root of x, x to the third minus 2. When you plug in an infinity, you will get infinity over infinity. This cannot be determined. It is not equals to 1. No. Infinity over infinity is not equal to 1. 0 over 0 is not equals to 0. Whenever you see infinity over infinity or 0 over 0, they cannot be determined. So cannot be determined. We have to do something about it. Does conjugate work? Nope. The conjugate is not going to work. We have to do something for the x to the third in the denominator. But the biggest problem is that is in a square root. Can you just divide each term by square root by x raised to the third? Nope, that is not going to work either. In order to bring a x to the third inside, we have to do this. So this is what we have to do. We have to do a fraction, 1 divided by x to the third. And we have to wrap this up by a square root. And then we do the same thing for the top, 1 divided by x to the third. Because why? Because if you have a root a times a root b, since they are both in a square root, then that is square root a times b. So that's why we have to wrap the fraction by a square root. What happens if you have a fourth root or a fifth root? Then you have to do a 4 right there. Yeah. That is the only way to bring the fractions in. Okay. So let's don't change the problem because that is another story. All right, what is the next step? The next step, we have limit as x approaches to infinity. So we bring it in. X to the third divided by x to the third. 2 divided by x to the third. Oh, what about the top? The top is x divided by x to the 1/3 becomes what? that is the root 1 divided by square root x to the third, so that becomes a 3 over 2. All right, still remember your rational exponent, your radical thing, right? Okay, limit as x approaches to infinity, the denominator, we have a 1 minus 2x to the third power, the fractions becomes 0. What about the top? The top is the top you have a 1, right? So the top in here you have a 1, then you have a degree on top minus the degree on the bottom, so that is equals to 4 minus 3. 2 minus 3, that is equals to negative 1 half, right? So negative 1 half. So negative 1 half. So x to the negative 1 half is what? 1 divided by x to the 1 half. So the top becomes 1 divided by x to the 1 half. And then you have 1 divided by square root, that is equals to 0. So the top is equals to 0. The bottom is a 1 minus a 0. So we have a 0 divided by root 1. This is equals to 0. 0 divided by any non-zero value is 0. Again, 0 divided by any non-zero is equals to 0. But 0 divided by 0 is cannot be determined. There is no way to decide what it is. When you have a 0 over 0 or infinity over infinity, you have to play some algebraic technique or whatever it is to evaluate the limit. Alright, so that is the end of this video. If you think this is helpful, give me a like, share, and subscribe. I appreciate your help and support. I will catch you all in the next one. Signing out.